Hi, I'm Jonah, and today I'm representing my team and CryptoNet Research Lab, and I will introduce you to our next release for the data retrievability protocol. You can get the slides following the QR code, and the slides are on IPFS. So we have been developing a technology that is needed to boost the use and trust in decentralized storage networks and services. And the issue that we have been looking at is how we guarantee the retrieval from the centralized storage networks. We know that mainly we have three flavors of primitives, so protocols that can help us somehow guarantee this kind of retrieval, which is never guaranteed. So data availability is okay for roll-up data or blockchain data, but still requires honesty, assumptions, and consensus on dispersal. Then we have proof of storage, but which doesn't have strong cryptographic guarantees that the file will be served. And then we have data retrievability, which is the answer that we are developing, which allow us to onboard unbounded data, so it's web scale. It's not relying on assumptions of one of n nodes, being honest, and it's good for NFTs. So for storage that must be long term. But we know that we cannot have a real proof of delivery. Anytime we need other assumptions, so third parties checking the things that are happening. There can be three ways of doing that. We can have blockchain as a witness, we can have proof of retrievability protocols, but those are slow and expensive. We are looking at something smaller and more efficient. So here comes the retrieval pinning protocol. Which basically is an oracle, so it's a trusted single party, third party, and it is decentralized. How it works? So basically, we have the referees, client, and providers. The referees at the moment are 5 online nodes, and we need to trust only 3 of them, even if the optimum size of the network will be 20 referees. Client and provider agree on the retrievability deal, which allows the client to set the duration, the payment, and the collateral, which will be stored, actually locked down and stored in the smart contract vault for the duration of the deal. And basically, what happens if the client doesn't get the file when it requests it to the provider? It can appeal to the referees. The referees basically will try for k attempts, which is a protocol parameter, to retrieve the file, asking it to the provider. If it works, the file is forwarded to the client. Otherwise, collateral is taken for the provider and the provider is slashed. So looking more specifically, the appeal has k rounds, and these rounds, as I said, are set via the protocol. At the moment, we have 12 rounds during 1 hour each. Anytime a network of referees wants to be part of the protocol, will be able to set its own terms of agreement. We have 2 steps for each round. Step 1, basically a leader is randomly elected, and the leader asks the file to the provider. If it doesn't get the file, it sends a failure message on chain, and we go again to step 1 for k times, so for a couple of rounds. If it gets the file, as long as this is a network of nodes, it serves it back to the client and also to the network of referees. If the referees have seen the file, it's okay. But if less than the majority of them has not seen the file, the referees network send a failure message, so a less message on chain. This happens for k rounds. After k rounds, we count the number of failed message, and we have a threshold. So if we have more than k slash message, the provider is slashed and collateral is taken. Otherwise, nothing happened, and the client can appeal to the referees many other times. Those times at the moment are 5, so 5 times during the duration of the deal, and still this is a parameter set by the protocol. Now we can go through the command line interface for the provider that we have developed, and we will see that the provider can sign up. While signing up, it can set the so-called price strategy, which means that it can set the minimum price, which comes from the size of the file saved in byte, size of the file per second per way. So this is going to define the minimum price that the provider can accept for the deal. The provider can also set the max collateral that the client can ask the provider to lock down, and also a max weight of the file. We are doing this in order for provider to accept deals automatically, and we want to make sure that the provider can actually retrieve the data before accepting the deals. Okay, and now let me walk you through the client user interface that we have developed last month. So it's brand new, it's online. There are still improvements and fixes to be made, but go try it, follow the QR code. Basically, you choose the wallet you prefer, you sign up. Here's the dashboard. Through the dashboard, you can filter the deals, check the status, see all the time remaining, download the file if it's available. You have information about the referees network, like referees IDs, the terms of agreement, as you know, and then you can create the deal. Creating the deal means that you have two ways of doing that: base mode and expert mode. So you upload the file, the CID is calculated. There will be more providers. At the moment, there is only one. So you choose the provider, the duration of the deal cost, which comes from the calculation that I told you about. It can also be free, but the minimum price is set automatically. And if it's not free, you can set also the collateral, which by protocol needs to be 1 per the value of the deal cost, the minimum collateral. After that, there's a pending transaction. Otherwise, you can create a deal in expert mode. The pending transaction will last 24 hours, and in those 24 hours, the client can cancel the deal if the provider has not accepted that. In expert mode, you are able to add more than one appeal address, so the addresses that can do the appeal. You can paste any custom deal URI, and you will be able to freely insert any duration, cost, and collateral. Still, we have designed, and we will improve that, a set of warnings that allows the client to go through the protocol parameters in a better way. And you can for sure request an appeal. The appeal, as you've seen, that right now costs 0.2 the value of the deal. We will go deeper into the appeal in the next demo, expected at the end of September. Now I want to talk to you a little bit about the milestones. You can go and check our GitHub board. So we are in milestone 1, which is about moving from prototype, so from the MVP to product to be tested. In the third release that it's to be expected at the end of September, we are developing the command line interface for the client to do the deals and the appeals. We are pivoting to on-chain storage, so we will design a more generic interface where you can have pinning deals, and also for each pinning deals you will be able to choose which kind of service do you want. In this case, retrieval pinning will be one amongst many services, and we will also audit the smart contract. About the next steps, I invite you to join our Slack channel because we're discussing about many things every month. At the moment, our open discussions are multi-referee networks and also being multi-chain, pivoting to on-chain storage and having this generic interface, and doing also user experience research. We are planning how to get feedbacks from early storage provider and referees designing specific programs, and we're also discussing how to use the Filecoin virtual machine. So thank you very much for your attention, and hope to hear from you soon.